So in this example, we want to find the power output required by a car to sustain its movement up an inclined plane. So let's begin. Find the power output of a 1,500 kilogram car that moves up an incline of 15 degrees with a constant velocity of 120 kilometers an hour. Now we're going to make the assumption that the force of air resistance is constant and is given by 700 newtons. So let's look at our diagram. Our car is moving up this inclined plane of 15 degrees to the horizontal, and it's moving at a constant velocity of 120 kilometers an hour. Now we're going to make the assumption that our x-axis is this guy and our y-axis is this guy. So what is the steps that we should take in our problem? Well, we know from the first and second law of motion that if our car is moving with a constant velocity, that means that there's no acceleration, and so our net force on the car along the x-axis is 0. So if we sum up all our forces, that will equate to 0. So our first step is to find all the forces acting on our car along the x-axis. And then once we find our force that's pointing in this direction, we can use that force multiplied by the velocity, and that will give us the power output. Remember, the power equals our force times our velocity. So let's begin by first finding all the forces that act on our object along the x-axis. So the first thing that's important to note is that the force of gravity is acting on our object, and it points directly perpendicular to our ground. So this is our force of gravity pointing downward. Now this guy is simply our normal force pointing in the opposite direction, and this angle is angle theta, or 15 degrees. So to find our force due to gravity that's pulling on our car along the x-axis, pulling downward, we simply take our magnitude, m times g, and multiply it by sine of the angle 15. So we get our force pulling down going this way due to gravity is m times g times sine theta. So that's the first force. And let's say going downward this way is negative and going upward this way is positive. The second force we need to consider is the actual force that's allowing our car to go up, and that's the force of friction. Remember, the motor is powering the wheels to turn, and then those wheels interact with the ground, and our force of friction pushes our car upward. So the force of friction is what causes our car to move in the first place, and in fact that's the same force that allows us to walk. So what's the last force we need to consider? Well, it's the force of the air resistance. When our car travels upward at a speed of 120 kilometers an hour, there's air resistance due to the air molecules in the air which are hitting the car. So let's say this force points in the opposite direction. It retards the car. It slows it down from moving. So we have one force, two force, and three force. So this way is positive, going down is negative. So let's add up all the forces, and remember this equals 0 because according to the first and second law of motion, since our car has a constant velocity, it's not accelerating. So this equals m times a, our acceleration, and since that's 0, this is simply 0. So force of friction is positive, everything else is negative. So minus the force of gravity minus the force of air resistance. So let's bring everything to one side and let's leave the force of friction on the other side. Remember, the force of friction is what we're actually looking for, because that will help us find our power. So we basically know what this guy is and we know what this guy is. So let's plug these in, add them up, and get our force of friction. So our force of gravity is simply 1,500 kilograms of mass times 9.81 meters per second, our gravitational field, multiplied by the sine of the angle that our axis makes with our ground. So sine 15 plus we said 700 newtons of power of force due to the air resistance going this way. So we add these guys up and we get approximately 4,509 newtons of force is going in this direction, right? Because we found what the force of friction is, which points upward. So the force going upward this way is the same as the force going downward. And that's why our velocity is in fact constant. So now we know what our force going up is, so let's use the power formula, which is given by force times velocity. Now notice the reason we don't have any sign here, or any angle here, and that's because we already took the sign into consideration in this part. So we simply have the force times velocity. So, and our force is 4,500 or 4,509. What's our velocity? Well, the velocity is not 120 kilometers an hour because we must convert this number into meters per second. So we multiply this by 1,000 because there are 1,000 meters in any kilometer, and then we divide by 60 times 60, or 3,600. Why? Well, because there are 60 seconds in a minute and 60 minutes in an hour, and we want to convert from hours to seconds. So we get 33.33 meters per second. We multiply the two guys out and we find that our power in watts, which are joules per second, is 150,300 watts. So this is the power output that's required to keep the car traveling up this incline of 15 degrees at a constant velocity of 120 kilometers an hour. Now this is approximately equivalent to 200 horsepower. So the car must have 200 horsepower of power so that it can travel up this incline with this much weight, or with this much mass and this much speed.